Welcome back to G Fun Facts Online. Today, we are turning our eyes to the southern sky to investigate a cosmic crime scene that has been hiding in plain sight for centuries. We are talking about the Large Magellanic Cloud, or the LMC. If you are in the southern hemisphere, you know it as a familiar smear of light, a satellite galaxy that looks like a detached piece of our own Milky Way. For hundreds of years, astronomers viewed the LMC as a peaceful neighbor, a quiet companion merely drifting alongside us through the cosmos. But that image of serenity has been completely shattered. New observations from NASA's Hubble Space Telescope have revealed that the Large Magellanic Cloud is not just floating peacefully, it is a survivor. It is currently enduring a violent history of resilience and near destruction. We are witnessing a galaxy that has been stripped of its protective shield, left naked but defiant in the face of the Milky Way's immense gravitational power. Let's dive into the details of this galactic collision. The story begins with a recent and dramatic discovery that has upended our standard model of how dwarf galaxies interact with their massive hosts. To understand what happened, we have to talk about something invisible: the galactic halo. Most galaxies are surrounded by a massive, spherical cocoon of gas and dark matter. In a standard model of galactic evolution, a galaxy the size of the LMC, which is a heavyweight among dwarfs at about 10% of the mass of the Milky Way, should possess a substantial halo. This halo acts as a reservoir of gas, the fuel tank for future star formation. Astronomers used the Hubble Space Telescope to analyze the halo of the Large Magellanic Cloud, expecting to find this massive reservoir. What they found, however, was a scene of devastation. The halo had been decimated. The gaseous halo of the LMC is roughly 10 times smaller than it should be for a galaxy of its mass. It has been sheared away, blown back like smoke in a wind tunnel. The culprit for this destruction is none other than our own galaxy, the Milky Way. Here is the physics of what is happening. As the LMC plunged toward our galaxy on its first ever close approach, it didn't just move through empty space. It slammed into the Milky Way's own vast halo. The space surrounding our galaxy isn't a total vacuum. It contains gas and plasma. When the LMC hit this medium, the pressure of the collision, known in astrophysics as ram pressure stripping, acted like a cosmic hairdryer. This force blasted away the LMC's outer layers of gas. To visualize this, imagine you are driving a car down a highway at high speed and you stick your hand out the window. The force you feel pushing your hand back is ram pressure. Now scale that up to galactic proportions. The Large Magellanic Cloud is plowing through the Milky Way's halo at nearly 1,000,000 miles per hour. The friction from this passage is so intense that it has physically stripped the dwarf galaxy of its own atmosphere. It is leaving a trailing wake of gas behind it, remarkably similar to the tail of a comet. This leads us to the anatomy of survival. What makes this event a story of violent survival rather than total destruction is the fact that the LMC is still here. Smaller dwarf galaxies would have been torn apart by such an encounter. Their stars would have been scattered into the Milky Way's halo, dissolved into long stellar streams, a fate that has actually befallen many other satellites, such as the Sagittarius dwarf spheroidal galaxy. The LMC survived because of its mass. It is a prizefighter. Its gravitational well is deep enough to hold on to its core stars and a significant portion of its dense gas, even as its outer halo was stripped away. It is battered, bruised, and bleeding gas, but it is still standing in the ring. This survival is critical for our understanding of the early universe. The LMC is thought to be a modern-day proxy for the high redshift galaxies that populated the cosmos billions of years ago. By witnessing its survival, astronomers are getting a front-row seat to the kind of violent hierarchical merging that built the universe we see today. We are watching a galaxy being processed, transformed from an isolated object into a satellite, losing its independence but retaining its identity. There is another layer to this survival story, and it involves the invisible backbone of the universe, dark matter. While the visible gas halo was stripped away by the ram pressure, the survival of the LMC is a testament to its dark matter halo. Every galaxy is embedded in a halo of this mysterious substance, which provides the gravitational glue to hold it together. The stripping of the baryonic, or visible halo, highlights the resilience of the dark halo. While ram pressure can easily push against gas, because gas interacts via fluid dynamics, it cannot push against dark matter, which interacts only via gravity. The LMC's dark matter halo likely remains largely intact, anchoring the stars and the remaining dense gas. This connects to another fascinating discovery regarding a different dwarf galaxy called Tucana 2. In contrast to the LMC's stripped state, Tucana 2 was found to have an extended dark matter halo, 3 to 5 times more massive than previously estimated. This discovery, made by tracking distant stars at the galaxy's edge, proved that even smaller, ultra-faint dwarfs possess massive dark matter shields. Comparing the two gives us a complete picture. Tucana 2 shows us the pristine state of a dwarf galaxy's halo before it gets too close to a giant. The LMC shows us the stripped aftermath of a violent collision. Together they illustrate the life cycle of galactic halos, from extended protective cocoons to stripped compact remnants. Now, let's look at the aftermath. Paradoxically, the violence of the stripping process didn't kill the LMC's ability to make stars. In some ways, it may have enhanced it. The compression of gas on the leading edge of the galaxy creates a bow shock where it meets the Milky Way's halo. This pressure can trigger the collapse of gas clouds, sparking new waves of star formation. Consequently, the LMC is currently a factory of new stars. It houses the Tarantula Nebula, one of the most active star-forming regions in our entire local group. This vibrancy is a direct result of its turbulent environment. It is fighting for its life, and in doing so, it is burning brightly. However, we must be realistic about the timeline. This survival is temporary in cosmic terms. The LMC is losing angular momentum due to friction with the Milky Way's halo. It is spiraling inward. In about 2 billion years, the long embrace will end in a total merger. The LMC will be consumed, its distinct spiral structure destroyed, and its stars added to the Milky Way's bulk. The stripped halo we see today is merely the first casualty of this slow-motion digestion. The ability to witness this stripped halo is a triumph of modern astronomy. It requires instruments sensitive enough to detect the faint, diffuse gas of a halo and the precise movements of stars. The Hubble Space Telescope's ultraviolet capabilities were essential for seeing the hot gas of the halo, a feat that ground-based telescopes struggle with due to Earth's atmosphere blocking ultraviolet light. This research marks a shift from studying galaxies as static island universes to viewing them as dynamic, evolving systems that are constantly interacting with their environment. We are no longer just taking snapshots of galaxies. We are watching movies of their lives, framed by millions of years-long frame. The stripped halo of the Large Magellanic Cloud is more than just a scientific curiosity. It is a scar of battle. It tells us that our galaxy is not a gentle giant, but a formidable force of nature, capable of stripping the atmosphere off its neighbors. And it tells us that even in the violent environment of a galaxy cluster, there is resilience. The LMC, battered and stripped, continues to shine, a beacon of survival in the turbulent dark. Thank you for listening to G Fun Facts Online. We will catch you in the next deep dive into the cosmos.